Welcome to DFAB Tutorials. This is RhinoCAM2, and we're finishing up our three-part flip mill. In this segment, we are going to finish off our flip mill with some profile cuts. So what I've done is I've taken my last piece here, and I've created a new file to where I just have this to work with. So remember, we want the bottom left-hand corner of our material on the origin point. And what I've done is I've also added some sides to this so I can create a box from it. And since we've already taken care of the registration marks, I no longer need those. And you can see that I have other points here as well, and these are going to be drill holes for screwing down my pieces. Just to explain a little bit of the nesting here, what I've done is I've created space in between profile cuts so I can add in create a frame around them, adding in these the screw holes. Since I don't want screw holes on certain pieces, this strategy works best, and that'll prevent the pieces from kind of wiggling around when they're being cut. So first, what I want to do is our tools are already loaded, and if you need to, go to RhinoCAM2 tool browser, and you can load your tools with this icon. The first step I'm going to do is my drill holes. So I want to select all my holes, or my points. Go down to the drill icon and make sure that they are recognized. And again, we're going to use the 1/8 inch drill. And from the previous tutorial, we used 18,000 for RPM, everything else is 50, and the cut feed is 240. The Z value is going to be our material thickness, 0.75 plus a 1/2 inch. So that gives us this number, and we want to make sure clearance plane is checked. For the 1/8 inch drill, I like to use deep drill setting, and we're going through all the way through the material, so it's 0.75 plus a little bit extra, 0.05, and that ensures we get a clean hole. Again, approach distance is 0.2, and we're going to cut this in half and do 2 steps. Here I have a lot of points, a lot of holes, so this is going to really help on the sorting. And hit generate. You can see it's somewhat organized. Next would be to cut our profiles first on the inside cuts. This is important because obviously we don't want to cut this outer edge first and then cut what's inside, because we might run the risk of it moving around a little bit. So for that, select your geometry, go back to 2.5 axis, and this time select profiling. Now we're doing this breaking this up into 2 different operations, because I have interior cuts, which are the ones highlighted, and then I have exterior cuts, which are the ones on the outside. So first we're going to do the inside cuts, and just make sure you have your regions selected. For this, again, the tool is going to be a 1/4 inch square end mill, and we use this tool for all our profiling. We like to run this at 20,000, and everything is 50 except for the cut feed. Now again, I explained it previously, but again, this cut feed is while the bit is engaged into the material, this is how quickly it's running through it. So we're asking the machine to run the bit 240 inches per minute through the material. Clearance plan should stay the same from the previous setup. In our cut parameters, this tolerance again is important, 1/1000th of an inch. And then our stock is set to 0. And we want a mixed cut direction. And this is important right here, outside inside cuts. We want to make sure that we check this box and bubble inside cuts. Cut levels, we are going all the way through the material. So your first cut, your total cut, is going to be 0.8. And this will vary. If you're following the flip mill, this would actually be different, just for the fact that there's only 1/8 of an inch of material to cut here. But if you're watching this tutorial to learn how to profile, we're going to treat this as if we're profiling through the whole piece. Sorry if that sounds confusing. It's just a matter of changing our cut depth. So on a normal profiling, you'll want your cut depth to be the material thickness, which we'll do here, plus 0.05. And that's 0.8. And again, our rough depth is 0.375, and this utilizes the sweet spot on the compression bit, giving us a really clean edge. And then for the finishing depth, we like to break this number down a little bit further to ensure longevity of the bit. And just as long as it falls in between 0.1875 and 0.125, we're good to go. So that works there. Make sure this is on depth first. This will save you time. And none on the entry exit. Don't worry about advanced cut parameters. And sorting, you want it on minimum distance. So we'll generate that. And if I zoom in, I see that my blue cut line is on the inside of my yellow geometry, and so we know we're good. And a good practice is just to kind of scan all your pieces to make sure that something weird didn't happen with one of your geometries and it's actually cutting on the wrong side. So I'm going to assume that this is good, so I can move on to my exterior cuts. So my exterior cuts, I can go ahead and select all my pieces, which I've grouped them ahead of time. And then I'm going to select this last line out here, and this line is going to lop off this unused portion of material, so I can use that at a later time. Again, we're going to profiling. My regions are set up. And the inside outside cuts, I should say, only work with closed objects. So you got to make sure that all your pieces or your geometries joined and closed together. We go to tools, same tool. Feeds and speeds are all the same. Clearance is the same, and the only thing that changes from the previous setup is going to be, we want outside cut. So now the bit's going to be going on the outside of this closed shape. Now, of course, this is not a closed shape on the right, but it really doesn't matter if it's inside or outside. Now this one is going to be 0.8 because we have all the material to cut through. And then remember 375. And just make sure this falls in the range, the specified range. Depth first is checked. that will make sure that each piece is cut out completely before it moves on to the next. And this will decrease your time a little bit. And none. Don't worry about this next advanced cut parameters and the sorting. Again, minimum distance. And hit generate and see what that looks like. So now I see that the blue line is on the outside of my orange geometry. And here on this open curve, the cut line is this representative of this red travel line right here. So it doesn't matter if this is on the left or the right. If I wanted to change that, I can simply just select that piece of geometry and type in flip. And you'll see that I need to regenerate this folder. And when you see a little flower come up on your folders, that means the folder is dirty and you need to regenerate. So I can do that by right-clicking, regenerate, and you'll see that it has flipped. Now, just real quick on placing your screws need to be at least a ½ inch away from any geometry that you're cutting. And this will ensure that the bit misses the screw. And that's if you're using the quarter inch bit, which we're doing here. And this concludes our profiling and the flip mill series.